part 2 of rational numbers, and we'll deal with equivalent fractions. So let's just review right now on the difference between rational and irrational. So which one is rational? What do you think? You remember from last video, you see these 3 dots, or more, sometimes people put 4 dots. This is an ellipsis, right? An ellipsis, and it's in math and it's in English. So in math it just means that there's a continuation here forever to infinity, and we don't know the next number. We're assuming, so we have a little earthquake there, we're assuming that it's 4, but we can't assume in math. So over here, this terminates. This number terminates, 0.123, so we know that this is rational. And remember the Q sign for rational. If we had something like this, problems with the video camera today. So if we have something like this, we know that it's also rational because it continues with a pattern, 1, 2, 3, 1, 2, 3, till infinity. Okay, so let's look at equivalent fractions. Here we have 3.25. So we know that as a fraction, this could be 3 and 25 over 100. It's a mixed number. And we know that this is a rational number because we have 2 integers here. 25 over 100 is 1/4. So this can also be 3 and 1/4. Okay, so let's look at this number here. So we can make this number a mixed number. We have the whole number 5. And we know that there's 3 numbers to the right of the decimal. And that'll be in the thousands place, so that would be the mixed number. We can also make an improper fraction. We know there's 3 numbers, again, to the right of the decimal, so if we move that 3 times, first we'll start with this. And we can just move it 3 times. We're actually just timesing by 1,000, and we'll get that. We just move it 3 times. And you can move on the bottom, on the denominator, you just add 3 zeros. So this would be the improper fraction. And it's the same as if you just did 1,000 times 5 plus 6, 7, 8. That's exactly what you would get. This is just an easier way. So what if we had this? What if we had 3.56? So we know it's 3 and 56 over 100. So we're timesing everything by 100. So we're taking 3.56 over 1. And what are we doing? Just moving the decimal twice on the numerator and the denominator. So this would equal 356 over 100. It's the same as if we just did 100 times 3 plus 56. This is just a faster way. Now to get an equivalent fraction of this, we can reduce, and we get an equivalent fraction. So once you reduce that, and see what you get. Okay, and I'll just write it over here again. So we had 356 over 100, and we can reduce that to 178 over 50. Maybe we can still reduce that. We can do 88 over 25, and they're all equivalent to each other. Okay, let's see if you can do one. What if we had 3.69? 3.69. How would you do that? So, again, we have 3.69 over 1. And we know it's in the 100th place, so you can just simply just move the decimal twice. If you're moving it twice, you move it twice on the bottom, and there you go. There's your improper fraction. What if you had a longer number? What if you had something like, let's make a bigger number, 45. Let's say 89017. So how many numbers are to the right of the decimal? 1, 2, 3, 4, 5. There's 5 numbers to the right. So remember the order here. We have 10th, 100th, 1,000, 10,000, 100,000. So we just move the decimal so we get a whole number, and we're in the 100th thousandth place. So there it is. Now, there's another way we can do this by getting the GCF. And I won't ask you to do this that much in class, but let me show you how it's done. Okay, let's try one just using the GCF now. Let's say I had a fraction, let's say 2 and let's say 3/5. So here we have a mixed number. Bring that down. 2 and 3/5. So we know that 2 and 3/5 we can just multiply. 5 times 2 is 10 plus 3, and we'll get 13/5. So there's our improper fraction. Or we could have done it the way we've done it in the video here. We know that 3/5 is 0.6, and we had the whole number, so we know we have 2.6. Right? Put 3 in the box, and 5 goes into 3. It doesn't, so it goes into 30, and it'll be 0.6. So what we have now is 2 and 6/10, which is equivalent to 13/5. It's also equivalent to 2 and 3/5. Now we could have got the GCF if we had 2.6 over 1. We know we moved it once, move that once, and we have 26 over 10. 26 over 10. We just moved it once. Move this once, move that once, we have 26 over 10, which is equivalent to 13/5 of all these arrows. Now, to get the GCF, we can look at the GCF of 26 and 10. So we put 26 up here, put 10 over here, and we know with 10 we have 2 times 5, and that's done right there. And with 26 we have 13 times 2. So we know the GCF, they only share a 2. So that's what the GCF is. So if you had 26 over 10, just divide it by 2. Taking the GCF. And you'll get 13/5, which is the number we originally started with. Let's do a harder one now. Let's say I had 8.16. I'm going to use the GCF method here. So again, we moved this twice. We'll start with this, step 1. We move the decimal twice. There's 2 numbers past the decimal point. We move the bottom number twice. The decimal's there, remember, we move that twice. So that's what we have, 8/16 over 100. So we can reduce this to get an equivalent fraction. Or we can find the GCF. So we'll take both numbers. We'll leave that there. We'll take 8/16 over here, and we'll get the prime factorizations of both of them. And we know with 100, we have 50 times 2. Circle the prime. We have 25 times 2. And then we have 5 times 5. So we have 5 times 5 times 2 times 2. Now with 8/16, bring that over. We can do 408 times 2. Keep breaking this down. Now we have 204 times 2. Again, circle all the primes. And we have 102 times 2. Remember, circle all the primes. And finally, we have 51 times 2. And here we have it. So you can see they only share 2 2's. The GCF is 4. So I'll leave that there for a minute to see how I did it. So now, if we can just divide both numbers by 4, and we'll get fraction in simplest terms. So you divide by 4 there, divide by 4 there. And then you'll get 204 over 25. Now there's an easy way to get the GCF, to get what the fraction is, that is, in simplest form, without even dividing. You can multiply by looking at this. Since the GCF is 4, if you get rid of the 2 2's that make the 4, you're left with 25. There's the 25 on the bottom. Get rid of the 4's here, and you're left with 51 times 2 times 2, which is 204. So rewind the tape and see if you didn't understand that, how I got that, just by eliminating the number 4, because the GCF is 4, so you eliminate the 2 2's, which is 4, the 2 2's up here, This is what you're left with. This is what you're left with, and that's the improper fraction. That's equivalent to this.